The topic of today's keynote is building trust from client to cloud, and we're very excited to have Mr. Girish Juneja, who's the Director of Intel Application Security and Identity Products from Intel. And with that, I'll go ahead and ask you to please welcome Girish.
Good afternoon. I hope you're enjoying your lunch. It's a beautiful location. It's the first time I've been here, but it's really a marvelous location. I also realize I'm holding you from the golf course, so I try to keep it short. I'm here to talk about security, especially security as it relates to ensuring trust between client and cloud. And, you may think, here's Intel, the hardware company, processor company, what do they know about security? And I think part of it is right. But we have learned a lot along the way as prior to our acquisition of McAfee about security. We have worked in some very large data centers. We have built software products, which actually you may not be aware of, that are security products that have been deployed in some very large international federal environments. And the reason we decided to come here and take this keynote role is to get an opportunity to talk to you, to understand better from you the security requirements that you see as part of this 25-point federal IT transformation and other initiatives that are in place in your environments. So at the end of it, if you have any questions or you want to kind of share some thoughts or you think differently than what we are talking about, I'll be more than glad to have an opportunity to talk to you, and we'll really appreciate that. So in the interest of time, I might skip through a few slides to keep it at 15 minutes. There are various drivers, as we have talked about in the last couple of days, for sharing of information. Essentially, the imperative has gone from security and silos to more information sharing, and security, therefore, becomes an important piece of that. I'll talk about the three pillars, the way we think about it in security, and share a bit about our longer-term vision and shorter-term elements of that security we are able to deliver. So none of this is going to be new to you. If you look at the federal imperatives, they're all about trying to reduce cost by using shared infrastructure, shared services. Despite having that, you have a regulatory requirement around FISMA, FedRAMP. If you were to think about PCI DSS, I don't know if the relevance of that, not in all agencies, but in some that deal with citizens. All those security issues that are driven by these regulatory requirements sometimes become a hindrance when thinking about the cloud. And the way we envision a cloud, if you were to think about what's Intel 2015 vision of cloud, we focus on three big things. We believe the cloud environments are going to be federated, which means you'll have some private cloud environments, you'll have public cloud environments, and you will have, in most cases, federated environments that are using some portion of public cloud and some portion of private cloud in order to deliver the services that your employees and the end citizens would need. So sharing data securely across these federated cloud environments is going to be a key. The second element as an infrastructure company, we believe, is that they need to be automated, which is you don't want to add another layer of operational overhead to move from private cloud to public cloud, or to move from a hybrid cloud environment to eventually using a portion of public cloud. And automated means what in this case? Automated means the virtual instances can be created, can be provisioned, can be managed, can be secured in an automated way without requiring a lot of operational overhead. The third, so these two parts I think are fairly obvious and things that you think about. The third part that we also envision is that the cloud environments are going to be client aware. We are moving into an environment where there are going to be more than 1 billion new devices added between here and 2015. These devices are going to be of all kinds, of all form factors, of all levels of security. And if you're going to enable your environments to be used by these clients, these client devices, you may have to think about how to make these cloud environments more client aware so they can offer capabilities that are driven from what level of security is offered in the client. That's another kind of key pillar, we believe, of the secure cloud usage. So the area I focus on in Intel is application security and identity, and I'll kind of bring the discussion to that and try, because that's the area I can actually provide some input and some perspective. When we think about application security and identity, we think about identity of what, of whom, for what purpose. And you got to start at the client, right? So you actually got to start at the user. So you have a user that needs to be vetted, needs to be provisioned. That user then need to attest themselves to the client device. They have to provide some credentials to attest themselves to the client. The client then have to attest themselves to an application or on behalf of some application. And then those credentials will be carried into public or private cloud environments where they need to be verified, authenticated, authorized, and secure access enabled. And then in the cloud environments themselves, you got to worry about the security of the virtual instances. There was a recent research at MIT where they were able to launch a side channel attack where across the VMs they were able to steal data from another VM instance. So you may secure the client, you may secure the access, but then the third issue becomes securing the cloud itself. So there are three pillars of this: securing the client, securing the access, and securing the cloud. And that's the way I kind of break it down. So let's talk about these three specifically. Clients, like I talked about, are proliferating in different ways. I mean, I'm sure you're getting pressures to allow people to use clients which are non-traditional PC clients, you know, phones or iPads or something similar of that nature. And the issue becomes, how do you make sure that access is secured? Now, the client capabilities are changing and will continue to change over the next 4 to 5 years. Some of the changes we are driving, some of the changes industry is driving. But in sum total, what it's allowing you to do is to have an ability to make a decision based on the security context of the client. What does that mean? So far, the client credentials have meant user provided some credentials to authenticate them on the network. And then there were some credentials in order to authenticate to the service that were provided on behalf of the device, carried on a browser, carried on an app, whatever the case may be. The additional capabilities that are coming, and then if you needed to do strong authentication, you will need second factor authentication, something like an RSA secure ID or some such device. Now, when you look at expanding that to a shared infrastructure, so basically expanding that to a much larger user base, that becomes cost prohibitive to scale. So some of the things as Intel we are doing is we are building hardware OTP capability in the device itself. So you don't need a separate dongle, you can authenticate based on the device. That does limit you from flexibility of moving from device to device. So there are use cases where it ends up being useful, there are use cases where it doesn't, and that's something that depends upon the particular application. There is also soft OTP, which is very widely used, which can allow you a movement between different devices, and it's very common, I'm sure, in your environments too. But the cost of soft OTP needs to come down much more for it to be widely used in the kind of citizen base we are talking about, millions and millions of people. Then, even if you had strong authentication, the client suffer from the ability, from the lack of security against attacks that are launched these days by not just hackers, but by professionals who are trying to steal very specific information, or even in some cases, nations that are trying to damage someone's infrastructure. We have seen examples of that before. So for that, in our hardware roadmap, we are building capabilities that would protect against certain kinds of threats that emerge because of these large-scale, highly capitalized attacks that are happening these days. And those attacks have to do with, zero-day malware. They have to do with taking over, putting a bot into the application, so man-in-the-browser type attacks. Those security elements cannot be done from software only. They have to be done by a combination of software and hardware capabilities, which is what we are architecting our future hardware designs on. So securing the client is one of the three important stools, legs of the stool, in order to secure the access to the cloud. The second one is securing the access. So what does it mean by securing the access? We were earlier talking about in the Canadian example about how do you vet identities when you provision users, so a very important element. The equally important element is how do you really make sure that it's really the user entering the credential and not some bot? How do you ensure that the I/O access between the input device for the user where they're entering credential and the application is secured, that channel is secured? So there is an important element of securing the access when the credentials are asserted from a user to the device. How do you secure that access? The second part is securing the assertion that goes from the client to the application. So federation here is pretty common. Most of you have many different federation solutions deployed. But when we look at the kind of examples that were shown earlier, where you have a community cloud and you have basically self-provisioning, self-service, many of these software systems available today are not as easy to deploy and as easy to ramp up as we may want to do based on the example that was shared. So the software requirements also change when you look at a shared infrastructure. It needs to be a lot more self-provisioning driven rather than having a large IT project to get from day zero to first use. It needs to be multi-tenant, of course, so that you can provision different sets of users for different applications and still allow for siloed auditing and other requirements you may have. So those capabilities are coming. Some of them we are providing, some of them the ecosystem is providing, and integrating that with user provisioning. So provisioning remains the soft underbelly of identity. Provisioning is usually the hardest thing to do in a way that it integrates nicely with your business workflows, with your own environments. And that needs to get simplified, not just federated access, but the provisioning of user also has to get simplified so that you can provision user against the set of services now that you want to expose as a set of shared services. That is something not typically done. Usually today when you provision a user, you know a very well-defined list of services against which you can provision. We are moving into a world where the set of services themselves are going to be dynamic and it's going to be very large. So how do you simplify that provisioning element is an area we also work in. The second part is, in many cases, when you look at social media, you look at the example of Workforce 2.0 that was shared earlier. Facebook is an often quoted example, but you can think of a Facebook for enterprise if you were to kind of take that example. Credentials in many cases are carried over APIs. It's not a browser to app interaction in most cases. In many cases, it's an app to app interaction. Even when you have a mobile app that interacts, it interacts over an API. So when you have these credentials that are carried over APIs, how do you secure not just the credentials, but the API themselves? Because there are a lot of threads that you can carry over HTTP. There are a lot of threads you can carry over HTTP and XML API. So that's another tier of security that needs to be thought through together with securing the credential. So that's another area we are working on. And finally, as you get into the shared environment, not all the users are going to be in your directory. Users are going to be in distributed directories. You're going to allow delegated access from other directories into your services. That's the only way to deliver shared infrastructure. And there has been a lot of work around specifications for brokering the attributes. I mean, you may be familiar with the BAE, Brokered Attribute Exchange model or standard, but that's still in the early stages. That has to get tied to the PIV credentials, that has to get deployed. There's some common infrastructure in federal government that is needed, which provides the attribute metadata, so you could actually share the attributes without having to build point-to-point connection with other agencies. So that's a fundamental infrastructure block in order to allow for real-time access to users who are not directly provisioned and controlled by you. The third leg of the stool is securing data and virtual machines themselves. This is an area, of course, of a lot of interest to us, just like the other two. So let's talk about these two separately. Let's talk about secure data first. Now, as you're moving your data into this shared infrastructure, whether it's developed, designed by you, or it's designed by another agency that you're sharing, who has the credentials to access that data becomes important. You may not want to give access to folks who are not authorized or for other regulatory reasons should not have access, such as some personally identifiable information. So the typical answer to that, in many cases have been, that's okay, we will do end-to-end encryption. Okay? End-to-end encryption has a large amount of PKI overhead. So you have to have PKI infrastructure in every place you need to decrypt it. That balloons the cost up. It balloons not just the cost of day one, but actually operational cost of maintaining and managing it. So there are some other capabilities that are coming into the market. So again, some of which we provide, some of which our ecosystem provide, that have to do with cloud data tokenization. So what that means is you are able to tokenize the data so that it is format preserving, it will work as that service requires it to work, but it is not in any way, if it leaks, it's not something that will cause serious damage to your application because it's tokenized. What you're getting is essentially a format preserved token. A cleanest example of that, or the most easy to convey one, is in PCI DSS domain. If you're familiar with PCI DSS, it is about securing the credit card related information so that you have less pilferage of that and a huge amount of fraud that happens around credit cards. So credit cards started the same way. They started by having, from the point of sale, encrypted, so the credit card is encrypted throughout the infrastructure. Now the problem is the point of sales are, and I'm giving a private sector example just to kind of show the analogy of that. The problem with that is you have one channel, which is a point of sale where you swipe the card, but then you have web, then you have back-end data warehouse where you're pulling all this data in. And that's where, if you look at Sony, if you look at TJ Maxx earlier, that's where most of the pilferage has been. It's not been from the point of sale, it actually has been from the back-end data warehouse where the information is in the clear. Now take that problem to a shared infrastructure, and you can see how it multiplies. Because now not only your employees have the access, other folks may have access. And therefore, tokenizing the information so that except for places that are highly secured, everywhere else where you're sharing, the information is tokenized, is available, but it's tokenized. And when somebody needs to detokenize it, they come back to your secured infrastructure, provide the right credentials, you have the audit log of why they looked at it and what was their authorization, and then give them that data. So that protects another layer of issues that arise in shared infrastructure where you're sharing data. That does not take away from cases where you may need to do bulk encryption in the cloud. There's enough examples where you have a large blob of data that you need to put in the cloud just because you don't want to change your application for a shared environment and a non-shared environment. You want to use the same infrastructure. So the easiest way to do might be to bulk encrypt the data that's in the cloud infrastructure. The challenge there typically has been the performance of encryption in general purpose processors. But there too, Intel has been building new technologies. I mean, you may have heard about AES-NI, which actually multiplies or reduces the time it takes to encrypt and decrypt AES encrypted data by a factor of 10 or something close to that. So it becomes actually non-cost prohibitive to do bulk data encryption when you're moving the data into a cloud infrastructure. So that's another problem statement and how we solve it. The third part of the data and VM is the VM themselves. So like I talked about, there have been new threats emerging as more and more applications move to a shared infrastructure that run under a fairly liquid platform, which is the VMs and hypervisor. So VMs and hypervisor themselves are software, and they are, as kind of susceptible to malware as some of the pieces that run on top of them. And the fact that the attacks have been somewhat less public and less announced doesn't mean that the weaknesses in those environments are less pronounced. As we see, typically attacks lag a new technology by 4 or 5 years, but when they come in droves, and it becomes very hard to then patch fix it. So there, what Intel is focusing on is what we call trusted boot. So essentially, when a VM boots up, they need to assert themselves to the hardware, and hardware only looks at the credentials presented by a VM, just like we talked about a user and a device and those credentials, and only allows for the VMs that actually are attested, that are testable, and are valid VMs that can be brought up. So in some cases, this protects against attacks like rootkit attacks. In other cases, it also helps in regulations that require you to not move your VMs in geography beyond a certain geographies, because we also use geotagging and other information in doing so. So you can't, for example, if you're putting something on Amazon Cloud, Amazon has multiple data centers, and then the VMs move to a country where you don't want it to. That can be controlled, and you can have a level of visibility into that, so you can make a decision whether you want to do it or not. So like I said, these three elements, securing the device, securing the access, and securing the data in the VM, is the way we look at different elements of security in the cloud. Just as an example of capabilities that we bring to market as a result of this learnings, we just launched, we acquired a company, you may not know the name of, McAfee, and we just launched jointly a cloud security platform where McAfee was already providing web and email security as a service. So, you may be aware of that. You can, instead of having web and email security infrastructure in your own environment, you can use it as a service. But the capabilities we added were around APIs and user access. So if in the cloud security platform now, not only the web and email can be secured, but a user can be federated to multiple cloud applications. A user's device can be checked for client attestation, so only a valid device gets access to a particular service. And then if there is a API-driven traffic, an app-to-app kind of traffic, that can be secured using this service. So essentially what this allows us to do together is to provide for a broader coverage of different cloud-based client-to-cloud interactions, whether it's web, email, identity, web services, APIs, and so on. So I think I'll keep it at that and let you move on to the golf course, unless you have questions that I can answer.
Do we have any questions?
I guess everybody's ready.
All right. Girish, thank you very much.
Thank you.